Hi everyone, welcome back to Causality with Boris, broadcast from SobolevSpaces. In this video I talk about potential outcomes of mediation. You learn about naturally occurring mediator values. Controlled, natural, direct and indirect effects are the three main topics in today's lesson. Make sure you watch until the end and compare the takeaways with your notes. As always, I've prepared a PDF that goes along with this video. Check out the link in the description and the PDF will be sent to your inbox. We find treatment effect by comparing potential outcomes. We observe the response to treatment and wonder what it would have been if treatment had been different. The key concept here is the potential outcome of alternative treatments. In a simple case of two treatments, we consider two potential outcomes for each individual unit. As usual, we let treatment variable x represent two groups. Treatment group is coded 1 and control group 0. Let's say treatment response y takes two forms, failure and success. Then we denote as y1 of u the value of the outcome that would have been observed if unit u had received treatment 1, and y0 of u would have been observed if the same unit u had undergone control treatment. The individual treatment effect is the difference between the two potential outcomes. In a population of units, the treatment effect is the average of the individual effects. In the presence of mediation, the treatment effect combines all changes in the state of unit u, produced through all causal paths, whether direct or mediated. In a population of units, changes in mediator state track changes in the treatment variable for each unit. In a sense, mediators are treatment outcomes too. And for treatment alternatives, we can think of potential mediator values in counterfactual situations. M1 of u is the value of the mediator variable that would have been observed if unit u had received treatment 1. M0 of u is the mediator value that would have been observed in the same unit u if it had undergone the control treatment. In causal diagrams, mediators lie on the causal path between treatment and outcome. Conceptually, mediators explain how intervention leads to the effect. If the mediator is not controlled, the otherwise independent treatment and outcome will appear to be related. Naturally, conditioning on the mediator would block all causal paths between treatment and outcome, all but the direct path, which is not cut off by any mediator. But how does one condition on the outcome of treatment? Certainly not through a randomized experiment. Mediators are treatment outcomes too, right? However, we can speculate about what happens if we control the mediator. Such reasoning about a hypothetical situation is a thought experiment. The problem is how to interpret the notion of conditioning on the mediating variable, which is the essence of the direct effect. Obviously, we should be talking about holding, even if hypothetical, intermediate variable to a constant value. First idea, we can consider setting the mediator at the same level for the entire population. Then we compare all treated and all untreated units with the same mediator values. The direct effect then is the expected change in outcome. The effect, of course, will depend on the value of the mediator. We call it a controlled effect because we set the same mediator value for each unit in the population. For example, if the mediator variable is binary, the direct control effect is the difference in outcome when the mediator is present and when it's absent. This is where the problem arises. In their 1992 paper, Robbins and Greenland argued that no two-factor experiment will distinguish between the effect of treatment and the effect of a change in mediator value caused by treatment. Factorial here means allocating units over different combinations of treatment methods and mediator values. Let's take a look at our example of surgical timing and mortality. Let's assume the occurrence of complications were a true intervention. Even then, substituting complication rates induced by delays for the rates after early surgery is not the same as conducting an experiment in which treatment groups had fixed complication rates. After all, complications are also the result of surgery. Well, we can still speculate what would happen if the complication rates after delays had been the same as after early surgery. We have two immediate causes of treatment outcomes: treatment itself and mediator. We can think of a third type of potential outcomes. The first two are treatment outcomes and mediators. You can see they are multiplying rapidly. Let y1 m1 of u be the potential outcome for unit u if it had been exposed to treatment 1 and mediator value m1. That is the same value that it takes under treatment 1. On the opposite side, let y0 m0 of u be the potential outcome for unit u if it had been untreated and exposed to the mediator value m0, the value that mediator would have taken in the absence of treatment. Same as in the control direct effect, we can compare potential outcomes in each unit u, treated and untreated, with the mediator set to a specific value. But here, the mediator is set for each unit individually. Natural direct effect in a population is the average change in outcome when the mediator is set to values naturally occurring in untreated units. And whether treated or untreated, it's the value m0 had the unit not been treated. Fundamental to this analysis is the concept of naturally occurring values. We assume that the mediator value in response to treatment varies from unit to unit. This variation is governed by factors related and unrelated to treatment. By the way, we call this direct effect natural because the mediator takes on naturally occurring values, and these values may vary across units of the population, naturally. In this thought experiment, we are looking at three hypothetical situations: all treated, all untreated, and all treated with mediator values as if in the untreated group. I label these situations A, B, and C, and then speculate whether the treatment effect would change if I compare situations A and C instead of situations A and B. In the binary case, the mediator takes the value 0 or 1. Therefore, situation C means that all factors determining the presence of or absence of the mediator among untreated remain in play. This ensures that its presence would be the same for each treated unit as if they remained untreated. Far from artificial, this thought experiment corresponds to weakening or strengthening causal paths between treatment and outcome. Consider our example with timing of surgery. First, we estimate the total effect of timing on mortality. We contrast the marginal risks for two situations. The entire population undergoes surgery after 2 days in hospital, and then the entire population is treated within 2 days. Second situation, we contrast marginal risk for the entire population treated after 2 days and for the entire population treated during 2 days, but this time we allow the proportion of complications for surgeries performed after 2 days. That's the direct effect of timing. Policymakers may be interested in the understanding the extent to which attenuating or enhancing causal paths may affect the overall effect of intervention. For instance, in surgery timing study, we are interested in mortality reduction that is unrelated to fewer complications due to early intervention. Indeed, the management of surgical complications may limit the effectiveness of policies to reduce surgical delays. In fact, mortality after serious but treatable complications depends largely on the quality of care. If effective treatment of complications is required to sustain the benefits of early surgery, then the direct effect of timing is limited. Or the indirect effect may be small compared with the direct effect. In this case, we speculate whether the treatment effect would change if we compare untreated and treated with the mediator levels typical for untreated. For the natural indirect effect to be non-zero, the treatment must change the mediator, and that change must change the outcome. For example, in addressing gender discrimination, a policymaker may be interested in assessing the extent to which gender disparities in hiring can be reduced by changing hiring policies or practices versus eliminating gender disparities in qualifications. In the first case, gender has a direct impact on hiring, and in the second, it has an indirect impact through qualifications. So here's the main message of this video. In causal mediation analysis, we looked at the response to treatment, and we asked what the response would have been if the treatment had been different, but the mediator level stayed the same. You learned that the direct and indirect effects of changes in treatment give an overall treatment effect. You learned how natural effects are related to naturally occurring mediator values. Don't miss the central idea of this reasoning. We look at three hypothetical situations: all treated, all untreated, and all treated with the mediator values if they were untreated. You watched another episode of Causality with Boris. Keep on watching.